Okay, all right. Good afternoon, everybody. It's a real treat to be here today. You know, this is such a different conference than typical sort of technology conferences. At NVIDIA, we do a lot of them. Probably one of the biggest ones that we do is the GTC conference. I don't know if you guys have been to those, a few of you. And there we always talk about products and technologies and go deep into speeds and feeds and whatnot. But this one is different, right? This is about you. This is about the AEC industry. It's about real users. It's about experts. You know, you guys are the experts. You live this every day. So in that sense, it's a real treat, and it's a pleasure to be here. The work that you do is phenomenal, right? It's I think we look at it as a perfect blend of art and technology that comes together. The work that you do inspires people. I think it evokes emotion. It impacts, I think, human society. But at the same time, there is all this advanced technology, the latest and greatest stuff that impacts you, right, and your work. And it's on that side that NVIDIA lives. Right? So the engineers, the researchers at NVIDIA, we're trying to understand what you do and your challenges and your dreams and your aspirations so that we can work on the right technologies and build the right products to make sure that you can do your work just a little bit better. Okay, so that's really what I think drives and motivates us. This is a beautiful image from KPF. You know, every design that you see now it's just spellbinding, right? It's organic. It doesn't even look like it was designed by humans. Right? There's so much of technology that goes behind it, including things like AI and whatnot, that you have to really understand the technology behind these kinds of buildings and cities and so on in the future. So I want to spend a little bit of time and give you a glimpse of what are we thinking about at NVIDIA. How do we think about the AEC industry? What's sort of our view of some of the challenges and opportunities here? And what's making things tick? When you listen to Carlos and the phenomenal work that he does at Neoscape, you heard from the Unreal Engine folks, right? I was in that talk just a little while ago. And who would have thought? A game engine company presenting at an AEC conference, right? That shows you how much the world has changed and how this technology is really imbuing in everything that you do. But I want to talk a little bit about what makes that happen. You heard things like real-time ray tracing. You know, the UE team was talking about that. Carlos talked about that. You're going to hear it from many other people. How does that happen? Right? What's the magic behind the software that makes real-time possible, for example? What makes AI possible in real time? So those are the things I want to give you a glimpse of all that. But let's start with a few challenges. Right? You guys have lots of them. I picked a few that are pertinent to the discussion. For example, design reviews. Right? We have talked to a number of architects and designers and so on in the industry, and the one common theme across all of them is design reviews. They're complex, they take time, there's so many people involved with different expertise, geographically dispersed, and they're all trying to make decisions, right? You're all trying to come together to make efficient decisions, and then that's not easy. It takes a lot of time, it can be cumbersome. So that's an interesting problem to solve. Predictable visualization, right? You saw a lot of that, you saw a live demo here, but it's about making decisions, right? You want to visualize something so that you want to communicate your design intent, and then you want to make some decisions, either in designing the building or helping your customers reach some decisions. So it's all about decision making at the end of the day. Remaining in the creative flow, if you're a designer, architect, whoever, you want to stay in that creative flow. The work you do is artistic. Right? There is that innate sense of inspiration, and once you're in that moment, you don't want to break that. You don't want to wait. You don't want to wait because your computer is slow, or your software is slow, or or you got to do a batch rendering, or send a job to a cluster, and then wait for some time for it to come back, right? That breaks the creative flow. So that's an important problem to solve. Optimizing construction plans. Now, this is a whole host of issues, right? Whether it's logistics, whether it's material planning, whether it's maintenance issues, all kinds of things that happen in construction, right? All those can also benefit from technology. So these are some of the areas that we looked at as important things to solve. Now, the good news is that we are in a brand new era of visual computing. Some of these things are already here. This is not science fiction. We're not talking about a roadmap. This is not a vision, a 5-year vision or stuff like that. This is all real, right? This is all here now. If you look at interactive photoreal rendering, this is happening now. A few years ago at NVIDIA, we started, and some of you might remember this if you were at SIGGRAPH or other conferences, we sort of started this real or rendered thing. We had a DeWalt drill, that yellow drill, and we kind of said, well, is this real or is this rendered? And at that time, it was all about making sure that you couldn't distinguish one from the other. It was so perfect, right? And so we were on that journey for several years. And this last year, we actually cracked the nut and solved one of the hardest problems in computer graphics, real-time ray tracing. Right? This now happens in hardware, in our GPUs. This is the world's first, right? So interactive photoreal rendering is here. It's not fiction. It's here now for you to use. VR integrated workflows, right? This is another thing. Just a few years ago, it was about, gosh, choppy VR, and people were getting sick because the frame rates weren't high enough, and you kind of go, well, it looks promising, and someday I think I'll adopt it and whatnot. But gosh, I can't be in it for more than like 2 minutes because it's also choppy and makes me sick. Things have changed. Now you're looking at the latest VR headsets from HTC and others. They're wireless, you're not tethered, you're free to move around. They've got wide field of view. They're extremely high resolution, super smooth. Now we're talking, right? They've got technologies like eye tracking, biometrics. Now we're talking. Now you can use this all the time, right? So that's going to be an important element. Simulation integrated design. I'm sure you guys are familiar with this, some of the work that's happening at ANSYS, for example. Previously, you had this notion that design and simulation were sort of two different phases. It was kind of a waterfall. You did the design and you tossed it over the fence. There's some kind of sharp guys in the simulation world who did all the math and whatnot, and they figured out all the simulation, right? The CFD and all that. Well, not anymore. Now you've got software that is running concurrent to your design software, right? It's doing simulation as you're designing. So this notion of sequential design and simulation workflow, that's changing, right? You can now do simulation all the way from your design and through the rest of your workflow. Extremely important change that has happened in the workflow. And I'm sure some of you guys are already looking into that. And then, of course, AI. Right? AI is a helper. Right? AI is there to assist you. AI is part of applications, and they're all going to be ubiquitous to the AEC workflow. So all these trends, and we'll talk about all these things in a moment, but all these things are really, really important. And what makes this possible from our standpoint is RTX, NVIDIA RTX. This is our latest and greatest GPU. It's based on the Turing architecture. It's arguably one of the fastest, most powerful GPUs, the most advanced GPUs in the world today. Right? This is what made real-time ray tracing possible. It has RT cores that accelerate ray tracing. It's got tensor cores that accelerate AI. It's got advanced programmable shaders to give you that beautiful shading that you might use in visualization or in VR. It's got NVLink, so you can scale memory. Your data sets are massive, right? Tens of gigabytes, right? Because you want to visualize entire buildings, cities. You want to use real materials. You don't want to dumb it down, because then you can't make design decisions if you dumb down your data sets. So memory is important. It's got NVLink. VR ready, of course. Right? So this is what makes everything that you've seen from Unreal Engine or Neoscape and KPF and others that you'll see. That software is running on RTX technology. We are working very closely with them, and we're really proud of our partnership with them to bring out the best in their software with this engine under the hood. And of course, there's a whole software stack. We made it really easy for applications developers to build applications on top of this. So everybody from Autodesk to Dassault Systems to Adobe, Chaos, everyone's working with us on taking advantage of this GPU. Now, when we think about visualization, you've seen some beautiful content already. I've got a few clips from some of our other partners as well to share with you. Let's play one here. This is kind of a comparison of RTX on and RTX off. In this case, when you say RTX off, typically what you have is scenes that are quote unquote faked in a way, right? You've got a graphics artist who's used graphics techniques to make it look real, but it's not actually real, right? It looks real, but it's not actually real. The difference is when you use ray tracing, when you have the liberty of this RTX GPU under the hood, now you don't have to fake it out. You don't have to compromise. Now you can actually let the physics of light do its thing. You can let the physics of light do its things with materials, like this chrome surface here. The reason why that warped image, the reflection looks right, is because it is correct. It's actually using the true physics of light in terms of its reflection, refractions, absorption. It all depends on the physical properties of that material. It's taking into account all that when it creates that reflection. That's the power of real-time ray tracing in hardware, right? You don't need graphics artists to sit and fake it out, right? Let light do its thing. Let it go, and you'll get real results. Here's another scene, similar reflections. Now it's a daylight scene. Again, if you look at a scene like this and you're confident that what you're seeing on the screen is a true reflection of reality, then you can make the right decisions. Right? If you think that it was created by a graphics artist, how can you make a good decision? You can't, right? And that's when you need to build a lot of physical prototypes. But if you can trust what you see on the screen, then go ahead, make that decision, choose your materials, place the orders, do whatever you need to do. That's what we are trying to achieve for you. Okay. Here's the Helsinki one. I think in the morning I saw the same model in the Unreal sizzle reel. But this shows you with and without. Right? If you don't have this stuff all turned on, you're not going to get the correct behavior of light. When you look at shadows, when you look at reflections, it's just not true. It's not real. But when you turn all that on, now you can see reflections and translucency, ambient occlusion, global illumination. With everything turned on, you can do all this thing interactively in real time. And our goal is to not do this only at the end of the process. Right? Our goal is not to just relegate this to the final frame rendering, final visualization stage. No, no, no. You can do this, if you're an architect, if you're a designer, you can do this every day. You can do this as you're designing. Why not? You've got the hardware, right? It just works. You use Unreal Engine, you use Neoscape, you use any of your other software. If it just works with the right hardware, why not use it in your daily workflow? You don't need a graphics specialist sitting there that you have to send him a job and say, hey, Joe, I got a render. Can you do this for me? As the guy's, okay, come back next week, blah, blah, blah. You don't need to do that. Put this hardware in your desktop, and you can do this on your desktop. You can do this on your laptop. Right? That's the power of RTX. Here's another scene from our friends at Build Media, also working with Unreal Engine. Just beautiful, right? You can see true reflections. You can see translucency effects and so on. Lighting is great. It's correct. You can decide what you want to do with your materials. You want to move lights in and out. Do that interactively. See how the lighting changes the mood of the space. Right? That's the power that you now have in your hands. Okay, switching gears a little bit, real-time engineering simulation. I talked about this already, but check out the ANSYS Discovery Live software if you guys haven't looked at it or if you're not familiar with it. Right? This is all based on GPUs. And this is what enables you to do true design integrator simulation. It's extremely powerful. You won't even know it. The simulation is running all the time. You make a change to a building. You want to figure out how the smoke dispersion is going to happen through a city block. Maybe those are the studies you're doing. Maybe you're doing lighting studies, reflections across buildings, and so on. All that simulation happens in the background all the time. You don't have to wait and do this iterative process where you then have to send it out to a simulation specialist, get the results back, and go tweak your design. Do it all the time. Leave the simulation running all the time. It works on the GPU. It's meant to do that. Right? So again, extremely powerful technology. VR. You're going to hear more about VR from other speakers as well. But VR is really impacting AEC through and through. All the way from design reviews, construction rehearsal, right? You can do a lot of the maintenance work or planning, construction. You can do that in VR. Training, of course, marketing and sales. So VR is here to stay, whether you're using an HMD or a different kind of immersive technology like even CAEs. All those technologies are extremely important, extremely relevant. They rely on the GPU to give you that smooth, beautiful, interactive experience. You don't get sick, right? And it's not just about VR being in that one-to-one scale, which is really what matters to you, that you can make that design decision once you know that you can trust the space. It's about photorealism. Imagine if your VR was truly photorealistic. Now, it's like being on the holodeck of the Starship Enterprise. You can't distinguish, right, reality from virtual reality. So we've been working hard on Project Holodeck. You guys have heard about it before. We've been talking about it. We are continually making improvements to it. Just a little glimpse of what that future is going to look like. But you have full environments to scale. You have avatars that are getting more and more realistic now. It's not just floating heads or just two Mickey Mouse arms grabbing things around. Now it's going to be full avatars, right, that are AI-powered, that move and behave correctly, proper animations and so on. So that makes it more natural, right? Makes it natural. You can be fully immersed in it. Obviously, moving around in the environment is easy. You can even pull in collaboration. Right? You can get people in different parts of the world on different computers or phones or whatever to dial in to that environment and interact with them. Right? It addresses your collaborative review problems. Right? So I think those are some of the things that are really, really important and we are excited about. Omniverse is another area that we're working hard on. This is a place where you can truly collaborate with people from anywhere in the world. And in this case, collaboration is not just to review something. You can actually do design while you're collaborating. So imagine if you have a designer and you're saying, well, gosh, that skylight, let's open it a little bit more and see what kind of effect it has in the light in the lobby of this hotel. Well, you don't have to do the traditional way where you would have said, hey, Joe, can you go and make that change and let's have a con call again in a week and then let's go talk about it? Well, Joe's on the phone with you right now and he's making that change right now in real time so that you can see instantly what that change is going to do and how that's going to change that lobby lighting. Or if you want to change the material, this artwork that you want to put there, well, have the designer make the change right now. Apply the material right now, and instantly you're going to see in a photoreal environment how that's going to look. This is true collaboration, right? This is real-time, instantaneous, anywhere in the world, any client. This is what you can do. So this is Omniverse. This is what we're working on. This is early stages, right? But stay tuned because this is going to blow you away. The next time we talk, we'll show you some more examples there. Quick word on AI, of course. You've heard of things like generative design. We are working very closely with Autodesk in accelerating AI for generative design, so you can get a great start when you start your design work. You have thousands and if not millions of choices to start with. It's all AI powered. But you need the hardware to make it go fast. And that's where the NVIDIA RTX GPU comes into play. We have tensor cores that are purposely built into that GPU to accelerate AI. Okay, so that's generative design, whether it's safety, compliance, surveillance, of course, design visualization we talked about. But all these things are powered by AI. AI is going to be ubiquitous in applications. Over 80% of apps are going to have AI by the end of this year, right? Commercial applications. That's huge. You won't even know that that's all happening in the background. But it's AI at work, okay? You can even take this beyond the individual. You can take this at a city level. NVIDIA Metropolis is a platform that combines our Jetson GPUs, small embedded GPUs that can be in very smart devices, all the way to Quadros at the edge, in really small, thin form factors like the LENOVO tiny workstation, right? Really beautiful little device that's got a powerful GPU in it. And you can do edge computing. You can put Quadros and Teslas in the data center. So all the way from an embedded IoT device to the data center, you got GPUs that can collaborate, that can share data, that can help you visualize, that can power your surveillance, that can help you optimize your city planning. That's NVIDIA Metropolis, so you can check that out. And then finally, this is completely new, right? You've heard of data science. You've heard of big data. There is so much data that's getting generated. Your companies are generating data, whether it's sensors or whether it's online or through customers, but all your companies are generating tons and tons of data. And the goal is to use machine learning, okay, to sift through that data and find those nuggets that are going to help you build better products and services. That's what people are doing. And so in AEC industry, that's extremely important. You've got tons of data, and you should be putting that to good use. So we have put together a special configuration that we call Data Science Workstation. This is for data scientists. This is for machine learning practitioners, and you have them in your companies. You personally today, you might not be a machine learning practitioner, but I can bet you that if you go back and talk to your people, there is a data scientist on your staff somewhere. Okay, and this is a configuration that we have put together with GPUs under the hood and with that software stack, so you can process this incredible, valuable data that your companies are collecting and turn that into business insight. Okay? So that's a data science workstation, and the reason I want you to be aware of this is because this is going to be an extremely important step for all you guys. Whether you're doing visualization or anything else, you're going to have this kind of big data analytics engine under the hood. And you should definitely check it out and go talk to people back home and make your data scientists aware of this. Finally, the products that are under the hood, tons of our hardware GPU cards like the RTX 8000, top of the line card, all the way down to 4000. Lots of memory, lots of horsepower, the fastest, most powerful desktop cards on the planet. And then this year, just a couple of weeks ago, we announced RTX-powered mobile workstations. Right? So this power of RTX now is coming to laptops. And this is super exciting. You already saw this in action with Carlos. He had an early LENOVO mobile workstation, right, which incidentally just got announced, right? It's super exciting. It's a phenomenal product, world's most powerful 15-inch mobile workstation. Literally the best on the planet. Powered by RTX 5000, 16 gigabytes of memory. This can do everything. It can do your rendering, it can do your AI, it can do your VR, it's got everything in it. But this is where the world is now, right? This is real this is the kind of horsepower that you have at your disposal to do the amazing work that you do, right? To change human society. And we are excited about it. This is what inspires engineers at NVIDIA to create these kinds of tools and work with our partners like LENOVO to build these amazing products. And it's always exciting to get a chance to talk to you and hear what's in your mind and get your input on how we can improve these things going forward. So that's it. That's our story. Thank you.